Alright, let's go. We missed a couple in the playlist, so we are doing 2017, paper 1, AddMaths. Let's get going. The function f of x can be expressed as, so they factorized f of x, so what we have to do, we just have to expand out the three brackets and see what the coefficient of x is. So I'm going to do something a bit smart here. I'm going to expand the first two brackets, which is going to be 2x plus 1 multiplied by x plus 2, which is 2x squared plus 4x plus x plus 2, which will be 2x squared plus 5x plus 2, and this was multiplied by x minus 3. So what I'm going to do, h is the coefficient of x, so I'm going to isolate the coefficient of x in this expansion. I don't need this here being multiplied by anything in the second bracket because I'm not going to get a coefficient of x. This multiplied by the minus 3 is going to give me a x term, which is minus 15x, and this multiplied by x is going to give me plus 2x. If you want, you could expand out this fully. If you don't understand what I did, just expand it out fully, and you'll get minus 13x is the x term, so h must be minus 13. 1/3 1 over x plus 3 plus that can be expressed as, alright, so there's a shortcut and there is a link. I'll put a link in the description for the shortcut to adding or subtracting any two fractions. Any two fractions. It could be algebraic, non-algebraic. Once you have two fractions to add or subtract, you could use this shortcut. 1 over x plus 3 plus 3 over x squared minus 9. I'll multiply these two numbers, giving me x squared minus 9. Multiply these two numbers, giving me 3 into x plus 3. I remain with a plus sign in between them, and I'll put it over when I multiply these two denominators together, which is x plus 3 multiplied by x squared take away 9. Expanding on the numerator, x squared minus 9 plus 3x plus 9. The minus 9 and the plus 9 goes away, over x plus 3 into x squared minus 9. Let's see if it have any with a x squared plus 3x on top. No. So we could factorize it up into x plus 3 over x plus 3 into x squared minus 9. The x plus 3 and the x plus 3 cancelled. Let's see if it has x over x squared minus 9. We have x over x squared minus 9. So the answer for number 2 is A. Number 3, if that is that, bada bam bam, completing the square. If you want, you could use your formulas, where A is equal to A, sorry. I believe the formula will be h is equal to b over 2a, and k is equal to c squared c minus a h squared. However, there are many ways to do this question. One way I do this question is simply completing the square. X squared minus 6x plus 13. I'll have x squared minus 6x in the brackets, and I'll add half the coefficient of x, which will be minus 3, to be squared, plus 13, take away 1 into minus 3 squared, because I added in this inside, x minus 3 squared, 3 minus 1 into minus 3 squared. I could jump on my calculator. 3 take away 1 into minus 3 squared is just 9. I get minus 6. I get a is 1, h is minus 3, and k is minus 6. Oh, I forget 13 is 13. So 13 take away 9, my bad, 4, positive 4. So 1 minus 3 and positive 4. 1 minus 3 and positive 4, the answer is B. The roots of the equation 3x squared minus 6x minus 5 is equal to 0 are, well, let's check and see what b squared minus 4ac is. A is 3, b is minus 6, and c is minus 5. b squared minus 4ac. Jump on your calculator. You are allowed calculators for your paper 1s for your AddMaths. b squared is 36 minus 4 into 3 into negative 5, 96. So b squared minus 4ac is greater than 0, so the roots are real and distinct. A quadratic equation is such that the sum of its roots is minus 2 over 3, and the product of its roots is 3/4. The quadratic equation is, so I know that the sum of roots is minus 2/3. The product of roots is 3/4. The equation that can give me the quadratic in terms of the sum and the product of roots is x squared take away the sum of the roots, x, plus the product of roots equals 0. X squared take away the sum of the roots, which is minus 2/3, plus the product of the roots, which is 3/4, is equal to 0. X squared plus 2/3 plus 3/4 is equal to 0. To get rid of the denominators, I'll multiply by 12. I'll end up with 12x squared. 3 into 12 is 4, plus 4x, plus 4 into 12 is 3, 3 3s are 9. So 12x squared plus, this is supposed to be 2x. So that will be 8x on top. 12x squared plus 8x plus 9 is equal to 0. The answer is A. The set of values for which this is greater than or equal to 0. For paper 1, you could make life very, very easy for questions like this. For paper 2, do not do what I am doing. But for paper 1, put the denominator equal to 0. I get 5x minus 2 is 0. And solve for x. X is 2/5. Put the denominator equal to 0. 2 minus 3x is equal to 0. I'm going to get 2 is equal to 3x. And x is equal to 2/3. Now we want to multiply the two x terms over here to see what kind of graph it is. If it's a smiley face or if it is a sad face. When I multiply the top and the bottom, I'm going to get a negative x squared term. Given that I have a negative x squared term, this is the scene here. My two answers that I got here and here will go on my graph. So 2/5 is the smaller fraction, and 2/3 is the bigger fraction. And I want to know where this is greater than 0. Wherever it's greater than 0, it's going to be above the graph, which is going to be in this portion of the graph. So the answer is x is such that x is going to be more than, x is such that 2/5 is less than or equal to x is less than or equal to 2/3. 2/5 is less than or equal to x is less than or equal to 2/3. Now I don't know why it doesn't have an equal to sign on the denominator, but it should have an equal to sign on the denominator to give me the answer to be D. There should be an equal sign on the, there shouldn't be an equal sign on the denominator, because if the denominator is actually equal to 2/3, I'm going to get this being divided by 2/3, and we have division by 0, which causes the universe to explode, and we don't want that. Number 7, the set of values for which 3x, I believe that is plus 2, is more than x take away 2. Move the x, I get 2x, minus 2 is minus 4. X is more than minus 4 divided by 2 is minus 2. D is the answer. If f of x is minus 2/9 x cubed, then we have the domain. We want to know what the range of f of x is. A good trick here, well, it's not really a trick, but it is a piece of information. Not all the time, when I plug in the small value for my domain, I'll get the small value for my range. And when I plug in the big value for my domain, I get the big value for my range. Sometimes you have to plug in more than one value to check and see what's the highest point and what's the lowest point of this particular function. So what I'm going to do, yes, it might take a little bit extra, but that's okay. Now, what I'm going to do, I'm going to write out f of x for the values between -3, -2, -1, 0, 1, 2, and 3, and work out what the corresponding values of f of x is. So we know that our f of x is equal to -2/9 x cubed. So what we can do on the calculator, I'm going to save -2/9 in a particular slot on my calculator. So -2/9, and I'll save that. Now let me save it in A. Okay, recall A, I'll get -2/9. So using this, I'm going to get A multiplied by -3 cubed. I get 6. A multiplied by -2 cubed. I'm going to get 16/9. Actually, let's leave it as a my mouse. Did my mouse disappear? Huh? Alright. Looks like my mouse little disappeared here. So we will work with what we have. That is 1.78. Then we're going into -1. I get 2 9s. I go into 0, I go get 0. When I go into 1, I go get A, which is -2 9s. -1, yeah. When I go into 2, I get A multiplied by 2 cubed. I get -1.78. And 3, I get -6. So the biggest value here is 6, and the smallest value here is -6. So when you all are writing the range of values for a function, the smaller value must come first when I'm writing the range of values. And if the smaller value is -6, then -6 must come first, +6 must come last. The answer is C. Number 9. The functions f and g are defined as follows. We want to know what the composite function fg of x is, so I actually want to know what f of 2x plus 1 is, which is going to be 2x plus 1 over 2x plus 1 minus 1, which is 2x plus 2 over 2x. Does any answer have 2x plus 2 on 2x? No, it doesn't, which means I need to do some manipulation with this particular function. Factorize it up. The x's, the 2's cancel. I get x plus 1 over x. X plus 1 over x, A is my answer. If the function, then m of 4 minus 2a is, well, I'll just replace in x with 4 minus 2a. 5 plus 2 into 4 minus 2a. 5 plus 4 to the 8 minus 4a. 8 and 5 is 13 minus 4a. The answer is D. If f of x, f inverse x is x squared minus 1, then, where x is greater than 0, then f of x is equal to, one thing you can do here, if I calculate the inverse of an inverse, I'm going to get the function itself. So let's calculate the inverse of f inverse x. So let y be equal to x squared minus 1, interchange x and y. X squared is equal to y minus 1, solve for y. X squared plus 1 is equal to y. So I'm going to get y is equal to x squared plus 1. None of these answers match. Did I make a mistake? Let's do it over. X squared minus 1, good. Interchange x and y, and then I solve for y. I get, oh, sorry, interchanging x and y. What I did, I just flipped x squared and y squared. So this is supposed to be y squared, this is supposed to be y squared. The root of x plus 1 is equal to y. The root of x plus 1, the answer is going to be b. 2 to the minus 1 divided by 8 to the power 1/3. Plug this in your calculator now. Nothing wrong with that. But we'll go through the rigorous working for it after. 2 to the power minus 1 is equal to a half. Divided by, open bracket, 8 to the power a third to the power of 1/3, close bracket. I get a quarter. Without using the calculator, 2 to the power minus 1 multiplied by 1/8 to the power 1/3 is the exact same question 12 written differently. 2 to the minus 1 is a half. 8 to the power a third is the cube root of 8. A half multiplied by a half, and we still get the same 1/4. 3x plus 27 to the m, and it's the root, the nth root of 3x plus 3 multiplied by 27 to the power m, which is 3 multiplied by 27 to the power m raised to the power 1/n. Nothing gives us that answer. In fact, all of the answers has a base of 3 except c. So I'm going to change 27 to base 3. 3 cubed. And when I have a base raised to multiple powers, I must multiply the power. Then I have an addition of two bases that are the same thing here. 1 plus 3m. And all of this was raised to the power 1/n. And I have to multiply the powers here again. So I'll get 1 plus 3m all over n to give me my power. So what I'll do, I'll just zoom in a bit here. And I'm looking for 1 plus 3m all to the all over n, which is the same thing as 3m plus 1 all over n. Right? I do apologize for the poor quality in this past paper. I unfortunately didn't locate a good paper 1 for 2017. The value of 2 to the power z, where z is equal to 5 plus log 3 to base 2, I'll get 2 to the power of 5 plus log of 3 to base 2. This is 2 to the power 5 multiplied by 2 to the power log of 3 to base 2. There is a law that states if I have a number raised to log of a number to the same base, and the bases are the same thing, this is just equal to b. So this is 2 to the power 5, which is 32, multiplied by 3, which is equal to 96. However, this law is not on your syllabus, so if you want, you could have just isolated 2 to the power log 3 to base 2, let that equal to y, and go ahead and use laws of logs to reduce that down. Right? But nothing wrong with using this law in paper 1. Given that log of x cubed to base 2, rub this off, get some space, log of x cubed to base 2 is equal to 6. The value of x is, I can use a law of logs to bring this 3 in front. I'll get 3 log of x to base 2 is equal to 6. Divide both sides by 3. Log of x to base 2 is 2. Use the log to index law, which will be 2 to the power 2 is equal to x. And I get x is 4. So number 15, x is 4. Number 16, given that log of x to base p is 6, log of y to base p is 4, the value of log of x over y to base p is, well, we have to take away the numbers, right? Using the laws of logs, log of x over y to base p is log of x to base p minus log of y to base p. Log of x to base p is 6. Log of y to base p is 4, and the answer is 2. But none of these answers here. Yeah. D. Good. I don't believe I didn't see 2 there on the denominator, yes? The common ratio of the geometric sequence is just 12 divided by 8. Let me see what that is. I like to make assurance doubly sure. 12 over 8 is 1.5, which is 1.5 or 3 over 2. The sum of the first n terms of a series is given by that. The sum of the first 10 terms is, now what we can do here, we can actually generate what the series is, get A, get D, because this is going to be arithmetic progression, get A and D, and then use S sub 10 to calculate the sum of the first 10 terms. So let's get the first term. The first term occurs, we have the summation, r goes from 1 to n of 5 minus 3r. The first term occurs when r is 1. So when r is 1, I'm going to get 5 take away 3, which is 2. This is A. Now I will have to get what the second term is to get what the common difference is. So when r is 2, I'm going to get 5 minus 3 into 2. 5 take away 6. 6 is that's minus 1, and this is T2. The common difference is T2 take away T1, which is minus 1 minus 2, which is going to give me minus 3. So this is R. If I could calculate what my last term is, which is T10 occurs when R is 10. 5 minus 3 into 10. 5 take away 30 is minus 25. Then S sub 10 is equal to n over 2 into A plus L, which is 10 over 2 into A plus minus 25. Work it out on the calculator. There's 23 minus 23 inside of here. This is 5. 5 multiplied by negative 23. Oh good lord, I had 10 of 5. 5 multiplied by negative 23 is minus 115. Oh, I was looking at number 19 for the answers, yes? So number 18 minus 115 is the answer. Number 19. So number 19 follows a similar principle to number 18. We have the sum from r goes from 1 to 5 of minus 1 to the r into 3 to the power r plus 1 is equal to. So they want the sum of the first 5 terms. So one thing we can do here is write out the first 5 terms, add it up. Another thing we could do here, and we should have done this for number 18, so take note of this. Write out the terms and check and see if it is a AP or it is a GP. With the experience, I know number 18 is an AP and number 19 is a GP. So you could always write them out and check and see if it's an AP or a GP. In the case of number 19, you can avoid that misconception by writing out all 5 terms and go ahead and adding them up together. So let me do that. We're going to have the first term being when r is 1, minus 1 to the 1, 3 to the power 1 plus 1, plus r is 2, minus 1 squared, 3 to the power 2 plus 1, plus minus 1 cubed, 3 to the power 3 plus 1, plus minus 1 to the power 4, 3 to the power 4 plus 1, plus minus 1 to the power 5, 3 to the power 5 plus 1. So we're going to calculator and take our time and work it out. This here is minus 1 multiplied by 9, which is minus 9. No problem. Plus, this is 3 3s are 9, 3s are 27. No problem. Then we go end up with a minus 3 to the power 4 is 81. Then we end up with a plus 3 to the power 5, I believe, is 243. Let's check it back. Then we'll end up with a minus, I believe that's 729. 729. So minus 9 plus 27 minus 81 plus 243 minus 729 minus 549. The answer is D. the sum of the odd integers between 10 and 50 is, you could go ahead and add it up if you want to. Now, one thing they should have included here, which could be a bit of confusion, do I include 10 and do I include 50? Based on the wording of this question, I will say no. So we'll go from, because they want the sum of the odd integers, they say odd integers, so it doesn't really matter. So I want from 11 plus all the way up to 49. I lazy. I real lazy. 11 plus 13 plus 15 plus 17 plus 19 plus 21 plus 23 plus 25 plus 27 plus 29 plus 31 plus 33 plus 35 plus 37 plus 39 plus 41 plus 43 plus 45 plus 47 plus 49, 600. You don't have to remember a whole set of bacchanal to get 600 to be the answer. Number 21. A line L passes through the point 6, 5 and is perpendicular to a line whose equation is 3x plus 4y take away 7 is equal to 0. The equation of L is, now given that they say that our L is perpendicular, I have to get a perpendicular gradient. So let me get the gradient of the line with the equation they give us. So I'm making some room by rubbing off. So I'm going to get 3x plus 4y minus 7 is 0. 4y is minus 3x plus 7. And y is minus 3/4. That's the only thing I'm focusing on. The gradient of the equation, and I want the gradient of L, which is perpendicular. Flip it and change the sign. I get 4 over 3 to be the gradient of the perpendicular line, which is L. And L passes through 6, 5. So we're going to use the equation y minus x1, y1. Y minus y1 is m into x minus x1. Y is equal to 4x over 3. Take away, 3 could go into 6 2 times, and 4 by 2 is 8, plus 5. Multiply everything by 3. 3y is equal to 4x minus 8 plus 5 is minus 3. Minus 3 multiplied by 3 on the denominator will give me minus 9. And it's just a matter of rearranging this to suit. So if I move the 3y on this side here, I get 4x minus 3y minus 9. 4x minus 3y minus 9. The answer is D. The lines intersect at the point P. The coordinates of P are, we could be lazy here again and substitute each of these points into the two equations and see if it works. Or we can solve them simultaneously. So again, I'm rubbing off to make a little bit of space. And let me solve them simultaneously. I'll take the second equation. I'll move the y on the right hand side. I'll get 3x take away 5 is y. And substitute y into equation 1. Minus 4 into 3x minus 5 is equal to plus 25, sorry. 7x take away 12x plus 20 plus 25 is equal to 0. 7 minus 12 looking like 8, 9, 10, 11, 12. Just double check, make sure. Minus 5x. 20 plus 5 is 45. Move it across, becomes minus 45. And I get x is equal to 9. Well, the only answer that has x is equal to 9 is part C. So I don't have to go and calculate y. A circle has center 3 minus 2 and radius 4. The equation of the circle is, and they want it in this particular form. That have two forms for the equation of a circle. In school, you all would have learned two forms. X minus a squared into y minus b squared is r squared. And you all would have learned either x squared minus 2fx plus y squared minus 2gy is equal to 0, or x squared plus 2fx plus y squared plus 2gy is equal to 0. I'm going to use the former, in which x squared minus 2fx plus y squared minus 2gy is equal to 0, where these two, f comma g, is the coordinates of the center. We have the center, which is 3 comma negative 2. X squared minus 2, 3x plus y squared minus 2 into minus 2 y, or plus c, sorry, plus c is equal to 0. And we could work out what c is. C is the square root of f squared plus g squared. Sorry, r is the square root of f squared plus g squared minus c. We have r. 4 is the square root of, well, if I square both sides, I get 16 is equal to f squared plus g squared minus c. 16 minus 9 minus 4 is equal to c. 16 minus 9 is going to give me 7. 7 minus 4 is going to give me 3. So c is 3. And I'm going to get x squared minus 6x plus y squared plus 4y plus 3 is equal to 0. I'm looking for a minus 6x and a plus 4y. And a plus 3. Minus 6x plus 4y minus 3. (16 minus 9) is equal to minus c. Good. And c is equal to minus 3. Okay, cool. So the answer is indeed c. Alright, another way we could have done this is by using x minus a squared into y minus b squared. So just to give you all that little bit of versatility in your exam. Oh Lord. X minus 3 squared plus y minus 2 squared is equal to r squared. X squared minus 6x plus 9 plus y squared, I plus 2, so I'll get plus 4y, and plus 4 is equal to 16. So we get x squared minus 6x plus y squared plus 4y. 9 and 4 is 13. When you bring the 16 across, 13 minus 16 is minus 3. And we get the exact same answer. Two vectors are equal if they have the same magnitude and they are in the same direction. The vector A is given as that a unit vector parallel to A is, now if you know anything about unit vectors, the unit vectors has a modulus of 1. We could scratch off A, we could scratch off B one time. It could either be C or D. So let's just check and see what the size of the vector C is. The size of the vector C is going to be the I component squared plus the j component squared, which is going to be 5 over 13 squared plus 12 over 13 squared, 25 over 169 plus 144 over 169, and we get 169 over 169, and it's going to be the square root of all of these numbers, which is square root of 1, so the answer is C. Now granted that I'm here to help everybody, a unit vector is u hat is equal to the vector u divided by the size of the vector u. In this case, the vector u is 5i plus 12j, and the size of 5i plus 12j is going to be 13, because I'll get 5 squared plus 12 squared. Square root is the size of the vector u. That is 25 plus 144, 169, which is 13. And just isolate the 1 over 13 on the outside. 5i plus 12g. So the answer is indeed C. OA is that and OB is that. AB by vector addition is AO plus OB minus OA plus OB minus 1725 plus 45 plus 17 plus 4 is going to give me 21, and minus 25 plus 5 is going to give me minus 20. So 21 minus 20, the answer for this is D. Number 27, the exact value of sine 150 over cos 150 is given as. So to make life real easy, instead of going through compound angle formula and expanding it out, let me be cheap. Let me go on the calculator. What is sine of 150 divided by cosine of 150? It's that. Now, there's a technique you could use here, right? If I square this, what do I get? I get 1/3. So if I square, and follow with me here, right guys? If I have sine 150 over cos 150 squared, I will get 1/3. Cool? So if I square root both sides, I'm going to get the square root of 1/3 is actually sine 150 over cos 150, because I'll square a squared. Square root of 1/3 is 1 over root 3. Now granted that the initial answer was negative, this is going to be negative here as well. Or another thing you can do, sine 150 divided by cos 150 is minus 0.577. Check and see what minus 1 on root 3 is. Minus 0.577. You can check what 1 on root 3 is, minus root 3 and positive root 3, and see which one gives you the exact same value as sine 150 over cos 150. Now by me explaining it, yes, I will take a little bit longer, but doing this in an exam, it's going to take you less than a minute to do a question. So the size of the missing angle X is, here we go, 34 plus 110, 180 take away 144 is 36 degrees. So 36 degrees to radians, we have to multiply by pi over 180, because I have to have a pi included in my answer. 36 over 180 is 1/5, so it's pi on 5. A very, very common thing that could happen here, I see people do this already, right? They get 36 divided by 180, and they get 0.2. And I say 0.2 is, some people do this, 180 divided by 36 and get 5. Alright, I've seen this happen already. So please do not make that mistake. Use the formula to get radians, you multiply by pi on 180. And to get from radians to degrees, we multiply by 180 over pi. Look, the next one here. Multiply by 180 over pi. 4 pi over 5 multiplied by 180 over pi. Bam, bam. 4/5 of 180. (144 degrees). The smallest positive angle in radians within the range that satisfies the equation is, plug in these values into your question. Pi on 3, it's smaller than 2 pi on 3, and that's smaller than 4 pi on 3, so the answers get bigger as they go up in the numbers for the selections. So I want the smallest number that satisfies it. If pi on 3 satisfies it, pi on 3 is the smallest number out of all of these, so the answer is going to be pi on 3. If pi on 3 doesn't work, I'll check the next one, and I'll check the next one, and I'll keep going until one of the answers work. So I'm going to change my calculator into radians. 2 cosine of pi on 3 minus 1 is 0. So this first thing is 0. 0 multiplied by anything will give me 0. So A is a valid answer. A is going to work. Sine of alpha plus 45 is equal to, well, we had to use the compound angle formula. Remember, sine of A plus B, sine A cos B, plus cos A sine B. So we have alpha and we have 45. So sine alpha cos 45 and cos alpha sine 45. Cos alpha cos 45 and sine 45 is 1 on root 2. So I could factor out the 1 over root 2, leaving me with sine alpha plus cos alpha. So the answer for number 31 is A. Number 32. If theta is equal to 5 on 13 and theta is obtuse, so obtuse means it's in the second quadrant, which means only sine is positive. I'm expecting tan to be negative in the second quadrant. So I know either A or B is the answer. If this is theta, sine theta is opposite, which is 5, over hypotenuse, which is 13. Brother man here gonna be 12. This is a Pythagorean triplet. Tan is adjacent, opposite over adjacent, which is 5 over 12. And I know that our tan needs to be negative. So the answer is B. Number 33. If sine of x plus 20 is cos x, find the value of x. So let me use the compound angle formula again. Sine x plus 20 is sine x cos 20 plus cos x sine 20, and this is equal to cosine of x. Let me rearrange. Sine x cosine 20 is equal to cosine x. I'm moving this on the right hand side and I'll get 1 minus sine 20. I'll divide both sides by cosine x first, so I'll get sine x over cosine x, and I'll divide both sides by cos 20 in the same breath. I'll get 1 minus sine 20 over cos 20. Well, this is just tan x is 1 minus sine 20 over cos 20, and x going to be tan inverse of 1 minus sine 20 over cos 20. 1 minus sine 20 equals, divided by cosine 20 equals, and tan inverse of that answer is 35 degrees. So the answer for 33 is A. The trigonometric expression is identical to, so I'll perform the little shortcut to the LCM. I'll get sine x into 1 plus cos x plus sine x into 1 minus cos x over 1 minus cos x into 1 plus cos x on the denominator is 1 minus cos squared x. You could go ahead and expand it out if you want. So my numerator going to be sine x plus sine x is 2 sine x. I expand it out and adding them in the same breath. And sine x cos x, take away sine x cos x is 0. And 1 minus cos squared x is sine squared x. You will cancel with one of the signs on the denominator, and I get 2 over sine x. The answer for 34 is C. Number 35. The differential of 7x squared plus 4, the root 7x squared plus 4, this is raised to the power of a half. The shortcut to the, let y, the shortcut to the chain rule is dy dx, treat the brackets as a variable. So I'll have a half multiplied by the variable, and I take away 1 from the power, which is minus a half. But I have to now multiply by the differential of inside of the brackets, which is 14x. Half of 14x is 7x, and this negative power makes the expression go in the denominator. Put it on the denominator, it'll be to the power of positive a half, and I get x squared plus 4. 7x over 7x squared plus 4. Number 35 is B. Number 36. At the point 74 on the curve, y is equal to f of x, dy dx is 0, and d2y over dx squared is equal to minus 5. The point 74 is, okay, cool. So at dy dx is equal to 0, that means it is a stationary point. And if the second derivative is minus 5 is negative, so that means we are sad, which means it's a maximum point. So part B. The gradient at that on the curve y is, we'll get dy dx. When I differentiate cos x, I get negative sine x. And then I'll plug in x to be pi over 6 to get the gradient. So minus sine of pi on 6, change the calculator to radians. So sine of pi on 6 is a half. So minus sine pi on 6 is going to be minus a half. Number 38. Given that y is equal to 2x squared plus 3 cos x, dy dx is 4x. When I differentiate cos, I get minus sine. 4x minus 3 sine x. The answer for 38 is C. Hopefully you'll hear me properly, boys and girls. The curve C with equation y is equal to f of x has a stationary point at minus 2 minus 5. If the second derivative is that, then the point minus 2 minus 5 is, just plug in x into that, I'm going to get x is minus 2. I'm plugging in f double dash of minus 2, which is the second derivative, which is going to be minus 2 to the power 4 minus 15. 16 minus 15, which is 1. 1 is greater than 0. So 1 is positive. So positive means we are happy. Once we are happy, we have a minimum point. Number 40. If the integral between 4 and 1 of f of x dx is equal to 6, then the integral between 4 and 1 of 4 f of x dx, so 4 f of x dx, the integral between 4 and 1, I can bring the 4 outside. So that is 4 the integral between 4 and 1 f of x dx. And we know what this is. This is actually 6. So there is 4 into 6, and I had to add 5 to it. 6 4s are 24. 24 plus 5 is 29. The integral of cosine x take away 2 sine x. So whenever I have differentiation or integration, more integration than differentiation, I will write down if y is equal to cos x, what is dy dx? Dy dx is minus sine x, which means if I integrate sine, I'll get negative cos. Similarly, if y is equal to sine x, dy dx is cosine x. So if I integrate cos, I'll get back sine. So the integral of cosine x minus 2 sine x. When I integrate cosine, I'll get back sine x. When I integrate sine, I'll get negative cosine. So this is sine x plus 2 cosine x. Sine x plus 2 cosine x. Part D has the 2 cosine x first. That's okay. And don't forget the constant of integration plus c at the end. The region bounded by the curve, the x, I see that integration question coming along. The region bounded by the curve 2x squared, the x-axis and the lines x is 0 and x is 1 is rotated 360 degrees about the x-axis. So when I'm rotating about the x-axis, it's the integral of pi y squared dx. If this is y, slap on a pi. Y squared is going to be this, 2x squared squared, which is 4x to the power 4. And we can't forget the pi. So it's pi integral between 1 and 0, 4x to the power 4 dx. The answer is D. For number 42, you could eliminate A and B because they don't have a pi attached to it. And we're talking about volume. Right, last stretch. If y is equal to the 3x squared plus cos x, then the integral of y is, we get 3x cubed over 3. When I integrate cosine, I'll get back sine plus sine x plus c, which is x cubed plus sine x plus c. The answer is B. Number 44, we actually have an integral to go ahead and evaluate here. So let's make a little bit of room. When I integrate that, I'm going to get x plus x squared over 2 plus x cubed over 3 evaluated between 2 and 1. Plugging in 2, I'm going to get 2 plus 2 to the 4. 4 divided by 2 is 2 plus 2 to the 4 to the 8. 8 divided by 3. Take away 1 plus 1/2 plus 1/3. Jump on your calculator. 2 and 2 is 4. 4 plus 8 over 3. Take away, open bracket, 1 plus 1/2 plus 1/3. 4 and 5, 6, or 29 over 6. We have the improper fraction 4 and 5, 6. Number 45, the region R is closed by the x-axis, the curve, and the lines, the area. So we have the integral between, instead of having minus x squared plus 2, I'm going to put 2 minus x squared. Between x is 0 and x is 1, dx, this is 2x minus x cubed over 3, evaluated between 1 and 0. In this case here, you should be experienced enough to know when I substitute the lower limit, I'm going to get 0. So I just have to substitute 1. So I'll get 2, take away 1/3, which is 1 and 2/3, which is 5 over 3. And that's it for 2017. Paper 1, 2018 comes next.